Everybody, it's 5 minutes past the hour, so I would like to jump right in. Thanks everyone for joining us. I would love to just do two quick logistics announcements before we jump into the content. Point one is this is being recorded, so by attending, you comply to being part of the recording. And then secondly is I've put all of the participants on mute except for the speakers at the start of the webinar. Please feel free to throw your questions into the chat. We'll either answer them as we go through the content, or we have actually some time saved at the end for a question answer. So with that being said, let me first just start by introducing what we're doing here. So this is the first session of a series of webinars that we're planning to hold, really geared towards people that are trying to build production quality LLM applications. We're going to try to cover both theory and the practice of what it takes to do this. So both the trends, the innovations that are happening in the space, but also the best practices and tips that you might want to use as you go about actually implementing things. And to do this, we'll try to bring a variety of people to come speak, not only builders like yourselves, but also perhaps investors and other interested parties in this space. So I hope you find this session informative, and I hope you join us for subsequent sessions as well. So this topic today is all about parsing unstructured data. We'll try to explain what this use case is, give you the theory about it, and then also talk about what it looks like in practice. So thank you for joining again. Very quickly, let me just introduce who you're going to be hearing from today. So on the left, you have yours truly. I'm one of the co-founders here at Horizon. If you aren't aware of us, we're a developer tool that provides a lot of the infrastructure to help bring production quality LLM applications into life fast. So whether that's finding the right prompt, selecting the right LLM, setting up a vector database, putting guardrails on your outputs and more, we help do that off the shelf. And then on my right, on the screen, I've got two of our wonderful guests from Massive. They are an innovative startup in the HR tech space, and we're very fortunate to be able to work with them. Dan, do you want to give maybe just a quick blurb on what you guys do over at Massive?
Yeah, we're an AI personal recruiter, helps you find and automatically apply to jobs. So we built a fine-tuned AI to fill out our job applications, help you find good jobs. I think no one's going to be applying to jobs in the future. I think kind of sucks. Also, I'm trying to get the chat popping, so that's where I'm going to be most of the time.
Awesome. Thanks, Dan. Thanks, Rohan, for joining. So let me talk through the agenda real quick. So for the next 10 to 15 or maybe even 20 minutes, I'd like to just share some of the learnings and theory that we have from this use case. And then we'll actually double click into the case study that Massive has of how they've actually done parsing unstructured data at a quite a large scale. And then we'll pause for a question and answer at the end. So let's jump into it. When we think about the use cases and the verticals that we could touch with LLMs, we at Horizon really think of this list, and this is by no means comprehensive, but you can see all of the different text-based applications, whether it's extraction, all the way to question and answer on the left-hand side, and then the verticals that we've been interfacing with, ranging from marketing all the way to legal and even data labeling and more. When we say parsing unstructured data, what we really mean are those first three elements on the left-hand side. It's extraction, classification, and summarization. You really need to be able to set up a tech stack that does those three things well, and it involves not only using LLMs, but also a lot of things before and after the actual calls to the LLM, which we'll talk about now. So of all those use cases that you just saw, like why is parsing unstructured data actually important, or why do we care about it? Well, let's think about the journey that we've gone through right in the industry. For LLMs, we had a few tools in our toolbox that we could use to do this job. You could either try regular expressions, you could go and offload it or crowdsource it with Amazon Mechanical Turk workers, or you had to be a machine learning expert, so the other end of the spectrum, and build your own models, engineer your own features, and it really took a lot to do this job well. But with LLMs, it suddenly brings this tool and this technology much more accessible, and so this ability to parse unstructured data is actually something that even Mechanical Turk workers are using to do their job. So the accessibility of this, I think, both in terms of the technical ability that's required and the latency that it comes with, as well as the price that it costs, I think suddenly makes this a much more interesting use case for us. So that's why we care about it. Let's talk about now the theory of what it takes to actually do it right. So there's quite a few components involved that I'd like to talk through. So the first thing is you need a curated training data set. This is important because you can try to just zero shot your way through to getting good output, but you'll probably either not get the best performance or you'll have to use a much more expensive model to do this. On the other hand, if you take the time to pull together a diverse and comprehensive set of data that really represents your task, so think of it as a training data set or a gold standard data set, that allows you to do either few-shot-based prompting or fine-tuning, which should either increase your accuracy and performance or allow you to use a much cheaper model. So that's one thing. As you go about doing this, I think data privacy is actually quite important. So think about to what extent can you share this data with your LLM provider or store it. After you have a good training data set, the next thing you want to do is actually experiment with many different prompt and model configuration options. So when I say prompt model configuration, there's a couple things that are involved in there. So when you think of the prompt, what you want to ask yourself, what is the right prefix for this prompt? What is the structure of the prompt? Like what prompting technique are you going to actually use? Are you going to use few shots? Are you going to use chain of thought? Are you going to use React? There's so many different techniques that you can use. So trying out different techniques is also important. And then on the model side, there's a few parameters themselves, right? So what is the right LLM provider for you? What is the right model within that LLM provider? What are some of the hyperparameters that you're going to take advantage of? So hyperparameters would include things like the temperature of the model. It would also include things like the functions API that OpenAI just released, right? And we can go deep into that. But just a quick blurb on functions, because I know that's particularly germane to this topic. The way functions works is basically the JSON schema that you describe in the functions parameter gets converted into a TypeScript-like format as a system message, and that's how it works under the hood. And OpenAI has fine-tuned their model to produce output that really follows the requirements of your functions. What we've found, just again to wrap this up, is functions is a really good way to steer the output in addition to guidance via the prompt or via few-shot examples. It's not a guarantee that the output will match your required schema. So we still think of post-processing as a very necessary layer. So in summary, functions as a parameter is another tool in the toolbox, not necessarily a replacement yet for anything else. But as you experiment with multiple prompt model configuration options, think about what is the cost that you're going to with each option, what is the quality that you're getting out of it, as well as the latency. I think all of those three are really the main criteria that you'd want to evaluate off of. The next thing is pre-processing input data. So why do we think about pre-processing? Well, the point is you really want to simplify the job for the LLM as much as possible. So think about the scenario where this is particularly the case. Suppose you're using long texts to as inputs to your LLM. Well, that's quite challenging. Well, it limits your ability to have multiple few-shot examples, and it also just makes the task for the LLM much more complicated. So if there's some inherent structure in the data that you're aware of, think about things like maybe the information that's relevant is only in the first few characters of the input text, or you can use some regular expression to extract the relevant section that's actually needed for the LLM call. All of that actually goes a long way in generating good outputs. And it's not even related to what model or prompt you're using. The next thing is a vector database. So this is particularly important if you're trying to do a few-shot based approach. Because if you are, you'd want to store that training data set in a vector database so that you can retrieve it in an efficient way. And retrieval is a huge topic in and of itself. But one quick recommendation on the fly is when you're retrieving few-shot examples, find ones that are both similar to your query string, but also diverse in and of themselves. So a common technique is to find a set of few-shot examples that are max marginally relevant for your query. And we found good results with that. And then at the end of the spectrum here, you see post-processing. I mentioned at the beginning that no matter what you do at the start, whether you put prompt guidance in the prompt string itself, or you use the function parameter, or you have a bunch of few-shot examples, none of that actually guarantees that the LLM output matches your output schema requirements. So you actually need a post-processing layer. One layer or technique that we found is extract the LLM outputs to JSON object and convert it into a pydantic model, which really guarantees whether it matches your output schema or not. And then what's also relevant in the post-processing layer is retries. So what happens if it doesn't meet your output schema? You could either just try to call the LLM and hope for better results. You could also try to be more intelligent and pass the error string or pass the original output along with in your second call to generate a more likely output. So those are the main components, but the last and certainly not least element is a feedback loop. So as you're deploying your LLM, you want this continuous optimization functionality, which takes outputs that the LLM is producing, and if they're good, it continues to augment your training data set or your few-shot example database. And if they're incorrect, you want to put corrections to those back to your training data set so that you can continuously improve future outputs. So in practice, that either looks like augmenting and continually building your few-shot database or setting up a new batch for fine-tuning. So this is really the theory of what we think of here, and I hope you'll actually see all of these elements played out in practice when we get into the case study. The next thing I want to talk about is whether to fine-tune or not. This is an interesting question because, as you've heard me talk about so far in the slide, I've mentioned that the two best approaches that really generate the best results, apart from just a naive zero-shot approach, is either a retrieval-augmented few-shot based approach or a fine-tuned approach. And I'd like to share a few thoughts on which path you should consider taking. This is a schematic that we found really helpful. It's one that Andre Karmpathy, who, if you don't know, is an engineering leader at OpenAI, produced. And for us, the way we think about it is you really want to be in this green or this yellow zone, which again correspond to retrieval augmented few shots or fine tuning. So what are the reasons why you might fine tune? Well, you might choose fine tuning if one of the following is relevant to you. One is you have a very narrow and well-defined task for which you have several examples that you can train on. So think of examples in the range of hundreds to thousands of examples that you can train on. It's also quite good if you have examples or inputs and outputs that are quite long in token length. So that way, if few shots become unavailable or not possible because of context or token limits, then fine-tuning is a way that you can get that training of your data set without having to pass it in the context itself. Those are really, I think, the best reasons that we've seen for why somebody would go about fine-tuning. One example of where we've seen it work well is we were speaking with a fintech company who is using LLMs to basically synthesize a lot of different data points into a summary for their customer support agents. Whenever they get on a call, they have everything from a variety of different data sources in their company synthesized for them. And this was such a straightforward and simple task that they were able to produce a large data set and fine-tune the cheapest OpenAI model, which is the ADA model. So that worked out well for them. What are the cons of fine-tuning? Well, the cons are, first of all, it increases the per token price. So right now, the fine-tuned ADA model per input token actually costs more than the off-the-shelf turbo model. So the per unit price goes up, and additionally, you do need a lot of training data sets, a lot of examples in that training data set, and then finally, you give up some flexibility, right? Because once you fine-tune a model, you're stuck with that. If the underlying foundation model evolves or there's a new provider out there, you have to re-fine-tune every time you want to switch models or you augment your training data set. So those are the cons for that. Because of that, we actually highly recommend from our own company to try retrieval augmented few-shot prompting first. The benefits of it are you get, in most cases, the performance that you need in terms of accuracy. You need much fewer data requirements, something as simple as 15 rows to start, or you could even use a synthetic data generator to help build it up. And you have flexibility, right? So if you have a few-shot database for one model, you can easily convert it to the next version of that model or to a different provider. And you can augment and continuously optimize on the fly. Every time you add an example to your few-shot database, your training and your output is just going to get better for the future without you having to do anything. And then lastly, of course, the per unit price of using this is cheaper. Like you can use the turbo model, which OpenAI just cut the price by 25% for the input tokens. So I think for the reasons of flexibility, for the reasons of ease of use to get started, and just overall cost, if you're more concerned by the unit price rather than the overall token length, I think retrieval augmented few shots is, for the majority of cases, the way to go. So that's our recommendation on this question. So hopefully those two slides, both in terms of the theory and in terms of this question specifically about whether to fine tune for this use case of parsing unstructured data, hopefully that gives you a decent framework to approach this. And so now what I'd like to do is actually start talking about Massive, and what I hope you'll see is an application of that theory in practice in what I consider to be a business critical use case. So Dan, I'd like for you to just start by talking about just the use case at a high level. Like what is the job you were trying to do? And then Rohan, I would love for you also to chime in after and just speak to the details of what is the inputs and outputs, what are the constraints of each, so that the audience understands some of the technical details around this.
Yeah, I think real life examples are the best. So look, Massive is pretty simple conceptually, right? It just finds and automatically applies it to jobs. It's a tool that does that. And I'm going to quickly share it just so you guys have context and you can see what we're dealing with. This is what the tool looks like. It's pretty simple. We have to do two things really well. We have to match you to jobs really well, and then we have to fill out applications really well. And for both of those use cases, we're using a fine-tuned AI model. And the costs were a little bit out of control. You can see one of the problems when you go on LinkedIn, Indeed, Wellfound, whatever, whenever you're searching for jobs, the accuracy is really bad. If you're searching for a product manager role in San Francisco, like you're going to get, roughly 65% accuracy anywhere else on any existing job platform. And that's pretty bad, right? If we said, hey, we're going to automatically apply you to all these jobs that you typically get on LinkedIn or Indeed, you're like, I don't want to apply to these random jobs. So we had to get categorization done, right? We had to categorize these jobs correctly. And we were dealing with a lot. We were dealing with job descriptions. We had to understand how to properly, like what roles they were fitting into, locations, salary ranges, all these different 15 or 20 different kind of categories that we had to categorize these jobs into so that we could ultimately do the thing that was valuable, which is automatically apply you. And yeah, that's the basics. We were using a fine-tuned model, and our costs were roughly $8,000 to $10,000 a month. And that was just uploading tens of thousands of jobs. Like it wasn't that many jobs. It was a handful of jobs in tech, handful of companies in tech, essentially. And Rohan can go into a little bit more detail of how we were doing that. But my main concern is, yeah, we're a startup. We've raised some money. But even for this small market that we were focused on, our costs were still like way outweighing the amount of revenue we could pull in. And so we needed to deal with that cost really seriously. Rohan, you want to dive in and explain how we kind of tackled that?
Yeah, so essentially the reason the costs got so crazy was we were using, like as Aditya mentioned, a fine-tuned model. We were using DaVinci fine-tuned. And our input prompt was thousands of characters, thousands of tokens. When it comes down to 2 cents per 1,000 tokens for DaVinci fine-tuned and really long job descriptions, it's going to get kind of out of hand. And we had 7 different parameters that we're pretty much trying to extract from it. We've got the title, sub-role, you guys are seeing all of them. But the biggest thing was we don't support every role that exists, and we don't support every location that exists, at least to start off, while we're trying to make sure we have categorization, we have jobs for every single categorization we can support. So the big thing for us was we need to make sure that the jobs are able to be sorted in one of 70 acceptable sub-role choices that we have between engineering, marketing, finance, so on and so forth. The tenure was going to come out within one of 5 acceptable choices, going from junior to expert level. And the biggest thing that our users really liked was job descriptions are full of a lot of fluff that nobody wants to read. So we wanted to condense down job descriptions into sub 500 characters with only the most important bullet points. So you can truly just graze through, okay, these are the important things, and I can move on to the next job if it isn't the right fit. So saving you time going through each of those. In terms of implementation for that, that's where kind of Horizon came in. We fine-tuned a model with a ton of data. We started off this whole process kind of using Mechanical Turk and us uploading a ton of jobs on our own. And that's where we got our original data set, and we used that to fine-tune the model, which was fine. It worked well. Like there wasn't a problem in terms of work. There was just a problem in terms of cost. Horizon enabled us to use 3.5, which is, what is it, 100 times cheaper, I think, rather than, did they correct me if I'm wrong? I think it's 0.002 versus 0.02, right? Yeah, 100 times cheaper for us to do, and we split it up into 7 different tasks, 1 task per role. So I can kind of go into the technical details a little bit and share my screen. 1 second.
And while you pull that up, the thing that's quite interesting to me and hopefully the audience is when you think about all the parameters that you were trying to extract, it hits all of those 3 NLP use cases that we started out with, right? You had text extraction when you think of the title or the pay fields. You have text classification when you think of the subrole, the tenure, and the locations fields. And you also have text summarization when you think of the responsibility field. So I think hopefully this is a good case study for folks as they think about parsing unstructured data across all those use cases. But please continue in terms of.
Yeah, absolutely. Couldn't have said that part better. So essentially we're grabbing, like we've got a database full of a ton of different jobs already. It's the unstructured data. And right over here is where we've got like all of our tasks that we're running. And those tasks where is it? We're making calls to Horizon, and we're only feeding in an X amount of characters for every single job. So this is like kind of the few shot example that Aditya was talking about. So for some of these, for stuff like role, like subrole, it wasn't helpful to feed in all, I don't know, 5,000 characters. It was only helpful to give it the first 200 characters. So we would end up splitting it out and only feeding it the first 200 characters. Then for what was the other one? Oh, for tenure, it was the first 1,000 characters for knowing like how important it was. Sorry, for chunking it out into knowing exactly what the tenure was going to be based on. Sorry, I'm losing my train of thought. Oh yeah, I can zoom in 1 sec.
Yeah, I was gonna ask the same thing.
Yeah, so for tenure, it was the same thing. We wanted to make sure that we were able to get the right tenures out, and we didn't want to feed it the whole thing because it was kind of an overload of data. We get to English jobs so you guys can see the inputs and outputs. Result. Okay, prompt. So we've got a prompt right over here where we are feeding it the job itself, or the job title, the location for the job, and then the job description. And the job description, as you can see, is really long. And what it'll spit out for us is everything in JSON, which is really helpful. So it'll spit out the tenure, the locations, all the things that we need in the correct classifications. And with locations, we only support like a finite amount of locations. If it doesn't support it, it returns null and we don't feed it to our database. So that's really helpful. And that's kind of like the way we're doing it. And it's been working really well. We were able to get parallelization working really quickly in here as well. How were we able to figure out? That was trial and error. That was something Aditya worked really well with us on how the few shot. Actually, do you want to go into that, Aditya? I think you know.
Yeah, I think part of it is domain knowledge, right, of your actual data set. So, for example, like when you look through your data set, locations is generally in the first 200 or so characters. The tenure and such can also be attributable or parsed from the first subset of characters. Certainly the title and most of these are within the first 100 or so characters. So a lot of this is actually domain knowledge that is taken from your own experience.
Right, yeah. And that's also the way that we were creating the prompts. Like our database does have it somewhat organized. The first couple characters will always have the title, and then it will have the location, and then after that everything comes after. And that's just like from our data sources that we have right now that we're able to organize the prompt in such a manner.
Rohan, could you zoom in a little bit?
More?
Yeah.
Yeah.
Maybe just, yeah, just one, if you could just show the audience just one quick stream of the input values, just the full length, and it's quite long, right? It's like, I think in the extreme case, it's over 5,000 characters, right? So think about an input length that would only support at most one few-shot example for something, for a model that has 4,000 or so token length. But you maybe want to just show that, and then show the JSON output that we can look at.
Let me get to one that's in English. Don't have control. Some of our companies aren't in the US, or they have non-American roles. Let me get to an English one so you guys can see that a little bit better.
I would also love to talk about the impact of like A versus B. A was us fine tuning previously, and we put in a ton of work to do that. I remember in December, we were just literally feeding kind of the fine tuning model by feeding it tens of jobs per individual role. So we would get a list of jobs, and we would have to categorize it manually to fine tune that model. And then every time we uploaded a job successfully, we would fine tune a little bit more. It was incredibly time consuming. I spent a week manually actually inputting hundreds of jobs in that way. And it got us to roughly 96 or 97% accuracy. So 96 out of 100 jobs would be properly categorized. And we were still throwing out a significant portion of jobs because they weren't being categorized, or mainly the token limits were being reached, and we just weren't chunking it down in this kind of unique way. With this approach, B, with Horizon and prompt engineering, like we got that accuracy up to 98%. I think it's 99% now, Rohan, right?
Mm-hmm.
I guess significantly more in a fraction of the time, just by kind of approaching it from a different angle. And the costs obviously, substantially down from like $10,000 a month to, I don't know, maybe $100-200 per month now.
Yeah, it's not an English prompt, but I think you guys will get the idea. This is the size of a prompt that we've got, that we feed, like that originally starts off, and we'll feed in an X amount of characters depending on what job that we're running, the jobs that we were mentioning were over here, the 7 that we split it into, and the output of that comes back like this. A much smaller subset where we've got all the information we need. Wasn't in English, gave it to us in English anyway. Great. That was, I didn't even know it was doing that up until I saw this. But we've got the coming back in 500 or less characters for all of our bullets, something that's very readable. Our sub role always comes back in where we need it. It's a sales partner, comes back as sales leadership. It doesn't always get it 100% correctly. Like we've got like this one, it did categorize as entry level and graduate. I think this one wasn't entry level and graduate for this one, but for the most part, it's almost always correct and it works well for us.
Yeah, Rohan, I don't know how we okay, I look at all the job applications that we upload, or all the job descriptions that we upload, and like Horizon has gotten more of them right than our fine-tuned model. So I don't know how the heck that actually happened, but I like looked at, hundreds when we were starting to use Horizon, and like it would categorize these random, like SDR, like sales development representative, and we would have a sub role of like business development, and we would have a sub role of like account executive, and it would like get that right, even though it didn't have the correct string in the title. I don't know how, but like that's an interesting point. Like it was just doing a much better job all the time. Yeah,
the way that the chunking works is like way better. And something else Horizon does that we're about to start using is the synthetic data generation that Dan was talking about. So like we had like a very tough time with creating data like for our first use case and like fine tuning the model. And that's like something that we're going to be using really soon. I'm sure that we'll talk about it in a bit too, of like creating data that works well. So we want to pretty much create a custom resume for every job application in the near future, but getting that data set up is very difficult for us. That's like a tool that we're going to be able to use real soon, and we're excited about as well.
Thanks for sharing this, Rohan and Dan. So let me take back the screen and show
one
folks.
quick point before we leave on the cost thing. Like I want to mention how serious this is. Like it's not just about saving cost. I had a conversation yesterday with a very big company. It could be a potential acquirer, it could be a potential investor, etc. And previously I'd used our OpenAI bill. I asked this question in the chat earlier. I'd use our OpenAI bill as like, a badge of honor when we were pitching to investors. Like, look at how much AI we're using, and they kind of bought it, which sucks. But when you start having like real value conversations, not just for your own company, but looking forward, maybe potential acquirers or investors or strategic investors, they don't care about that. They care about, hey, can this scale? right? Are your costs going to be way too high to actually scale this thing? How are you going to make money? And is this huge bill going to do that? So like now my conversation is, look how small our AI bill is. Like, look how much this scales. And it's a much, much more serious conversation. So I don't know if any of you guys are having that conversation. Happy to chat afterwards too.
Awesome. Okay. I think that should wrap up the case study. So in terms of the content for this webinar, I just want to wrap with a few next steps before we go into question and answer. So first of all, this is, as I mentioned at the start, this is the first of a series of webinars. We'd love for you to join our next webinar. We're planning for it on Tuesday, July 11th. And next, we're going to continue to share more tips and learnings as we go on our Twitter account. So please follow us there. And then the last thing is just an invitation to you. If you're working on productionizing an LLM application, we'd love for us to be a thought partner for you, whether that's in a use case like parsing unstructured data, as we talked about today, or something different. So please schedule time with us on that, and we'll paste a link in the chat where you can do that right after this. But otherwise, I'd love to open it up for question and answers. So if folks want to just raise their hand or paste their questions in the chat, that would work. And I'm going to allow everybody to unmute themselves. So I think the first person that I saw raise their hand, I believe it was you, Mizan Rahman. If you wanted to ask your question, we'd love to engage. Otherwise, if somebody else has a question, we can also do that.
Yeah, that was an accident.
No worries. Anybody else? Feel free to throw a question in the chat, or you can just unmute yourself and raise your hand or ask your question. Go ahead, Tim.
Hey, thanks guys. This was really interesting and awesome use case. Quick question on like how, I guess I hinted at it with my first question, like how would you have dealt with the use case where like, you know, same idea of wanting to extract certain piece of information, but you know, I guess there's two things. Like one is like our use cases, like the equivalent of the job search, the job description is actually quite long. We're talking like 50 to like 100 pages sometimes. And then also like, how do you kind of like vary dynamically like the number of parameters you're talking about? So for example, like we're having a harder time, like you listed out those 7 parameters, and for like tenure, for example, you had it down to like 5. I think what we're realizing is like there's a long tail of like stuff that we're getting, and just wondering like is it worth being comprehensive about like covering them all, or is it okay to probably just like bite off like the top 5 and call it a day on that one? So 2 questions in one, sorry.
Okay, so I think the 2 questions to repeat are, you have very long input data. So like what I heard was something like 50 or several pages of input data. So you manage token limits. And then secondly, your question was, how do you deal with classification when there's several or long tail of acceptable choices or categories is what I heard. Yeah. So I think if you have very long input data, you really have 2 choices. You either use a model that supports a long context length, or you chunk it and try to process it in parallel, right? So therefore, you can try to process one page or one subset of the text as you go. And if there's some way that you can predetermine what is the relevant section of that document for this particular categorization, that would be, I think, the optimal way. But given that, I think you'd have to process them independently and allow for the LLM to give an output in some cases where this page is irrelevant, right? So I think those are really the 2 main options. In terms of having a long tail of categories, actually, I think that's more solvable, because with Massive, they actually had in their sub-role field, they had 70 different categories that were acceptable, and some were way more popular than others. The trick is having a training data set that has examples for that long tail, so that when you get an input that is similar to that long tail, you at least feed the LLM the right context that it can find out about it. Does that make sense?
Yeah, no, that's really helpful. Thank you.
Yeah, absolutely.
Rohan, could you? I see there's a question here for costs. I'm estimating $300, but could you give
$300 and $400 a month for us, right? I just opened and checked, down from between 8,000 and 10,000 a month. So significantly lower. Neha, you asked about how I generated synthetic data for bootstrapping the models. It was Mechanical Turk for those first models. We didn't have any synthetic data, and we used those data sets that we had in order to feed them to Horizon. Synthetic data is something we're about to start using with Horizon. We haven't done it yet, but it looks really cool. If Aditya, you want to talk about that for her.
Yeah, absolutely. Yeah, just a quick blurb on synthetic data. So as we mentioned, like what we found with users, the hardest part is really bootstrapping that training data set. So with Massive, I think we were fortunate because they had thousands of examples because they had tried fine tuning before. Now with many other users, even getting up to 15 rows of data can be challenging because they have to self-manufacture that data. So what we wanted to offer was a way for people to just start generating 2 or 3 or 4 and then almost have a co-pilot that tries to generate the rest of the data. And that's what we think of as synthetic data generation. You can see the documentation in the chat, and it allows you to basically extend your initial data set and then pick, choose, edit to complement it before you go and actually implement it into production. So I see Daiki, I think you have your hand up. What is your question?
Hi, so I joined a bit late and I may have missed it a little bit, but I mean, obviously it seems like Horizon AI has like much cheaper cost basis compared to something like what OpenAI is offering. And I don't have a good understanding of like what a Horizon AI actually does behind the scene to make that possible. So maybe if we can kind of share a bit more on that, I think that would be helpful.
Yeah. So behind the scenes, what Horizon does is it really allows you to evaluate multiple different prompts and models, and also take advantage of a lot of the other infrastructure that we have off the shelf. So whether that's a vector database, whether that's guardrails or auto prompt generation. So these are the tools that we have in the toolbox. And so ultimately what we try to do is find the optimal prompt and model configuration. That's really it. So you could theoretically do it by yourself. Like you could try to go and figure out the right prefix string, set up a dynamic few-shot based retrieval mechanism with your own vector database, do all the pre-processing and the post-processing of LLM outputs, and achieve the same result that Massive did. But we've just built out that infrastructure because a lot of the users that we've talked to wanted to focus on the more differentiating aspects like their data, their user experience, and the commercialization of their product. Does that make sense?
Yeah, that makes sense. And I guess like the step process, is it pretty much like baked into the product, or is this more based on like individual case by case basis where you guys kind of provide more of like a, I don't know, like consulting-ish like guidance here?
It's primarily baked into the product, and the product is configurable to enable that. But we're very happy to collaborate as thought partners and make sure that every user is taken care of.
Got it. Perfect. Thank you so much.
Yeah, and just to like clarify in this particular case, like the reason why there was such a dramatic cost savings, as was mentioned, is we were able to go from a fine-tuned model to a off-the-shelf model, which was much more prompt and model engineered along with other infrastructure. So that was really the primary driver of cost reduction here. But to achieve that cost reduction, you needed the tools that I mentioned, whether it's pre-processing, post-processing, prompt generation, vector database. Those are the things that were needed to achieve that.
To add to your point, Aditya, and like focusing on other things, on other value add things, like one of the other features we want to tackle with Horizon is generating custom resumes, and this is something that like Rohan gets really excited by. But the idea is once we have all these jobs for you and we're automatically applying you, we have the ability to create custom resumes for each job, and the resume is the most important thing when you're applying jobs. But we built it during a hackathon. It was relatively easy, but the cost was like 6 cents per job. And if we're applying you to 50 jobs per week, like it gets out of control fast. So with the idea that we can bring this cost down to like, you know, fractions of a cent per job, now for us, this opens up the ability to not only add more value to our product, but completely blow away our competition at a lower price point too. Like I can't tell you how much of a differentiator this kind of can be in your business. I don't know what stages you guys are in your business, or if you're still kind of building early, but at this critical point when you're trying to differentiate and you're trying to compete in the market, the fact that you can offer a product that's vastly differentiated at a price point that's much lower is a value prop that's worked for history, essentially. So anyway, yeah, just adding more points to that, like just find these use cases of where you can like, where you're using AI, where you can lower those costs, and you can come up with a vastly different product, vastly better product, and you can compete much more effectively. I'm adding lots of context from the business side, right? This is all I think about. So maybe some folks here who find that helpful too.
Yeah, thanks for that. Any other questions folks have? Happy to go into the technical. Let's see. Synthetic data approach and how valuable that might be. Do you help them just with model and prompt conversion? Yeah, Maria, would love for you to speak up and maybe add some context on this. So for financial services customers, I think for any regulated industry, I think that what's interesting is the data privacy aspect. And also, I guess, the other functionality that people are using. So as I mentioned, one fintech user or prospect that we had was somebody that was trying to do customer support. Now, where the data is sensitive, there's really a few options. So one is you can try to anonymize the data when you're sending it to an LLM and then de-anonymize it as you get it back. We certainly think about, and with any other vendors that you work with, you want to be able to have a self-hosted version or at least a minimal amount of data sharing. So that's very thoughtful, worth being very thoughtful about. And then also just the overall like security that your LLM provider has. So I think a lot of these LLM providers are moving towards SOC 2 compliance, which hopefully helps mitigate the risks. But to your question about model and prompt configuration or beyond, I think the full suite of services is applicable, whether it's CI/CD or it's vector database setup or guardrails. Would be happy to chat more about your particular use case.
Awesome, thank you. Yeah, it's just I usually see companies that are kind of like either doing the model prompt configuration, so more of like a data science type of product versus developer and like whatever, everything that happens after that essentially. So I was just curious if you guys were thinking about it like more holistically.
Yeah, I mean, one part that I think is very important for anybody, right, however you're implementing it, is that feedback loop and that continuous optimization loop, right? That's even after you pick the model and the prompt. It's when you're in production and your users are thumbs upping or downing it. You want to take that data and continuously optimize it. Awesome. Sam, for the massive guys, would you ever train your own model so you wouldn't be subject to OpenAI's pricing? What would have to happen for you to consider that? Well, one thing to be clear is actually we are actually model provider agnostic. So we talked a lot about OpenAI in this particular case study, but we think of Anthropic, we look at Cohere, even open source models that are accessible via the Hugging Face API actually are things that we think about and for example, already support or are in our roadmap to enable. So I think from the start, we believe in having diversification in your model providers. The most simplest benefit of that is if one model provider goes down, you have a failover model, right? So that you can immediately keep your application live. But more than that, as you're hinting at here, you have some more flexibility rather than being constrained.
Yeah. I would also say it's not worth it. Rohan, you probably have a better answer to this, but it's not worth it for us right now, unless you're going, out to raise $150 million to build like a, AI personal recruiter LLM. And then you can sit there for a year, 2 years without launching the product, without testing all that stuff. Like, great. But for us, in order to prove the use case and have, accuracy plus minus 99%, it gives us more than enough to build the product, build an initial traction, get all the answers down so that we can go into a raise and to our future growth, like knowing what we're actually doing and being confident about it rather than sitting there and developing our own LLM. We've had this conversation a lot.
Yeah. This is just so quick to get off the ground that we can focus on other things. We don't have to focus on the LLM and spend a lot of time on that.
Everyone wants to do this. Like when you tell investors, like, we're going to build our own LLM, every freaking AI guy I know is like, oh, I'm going to build an LLM for this, LLM for that. Like, it's not going to work. You got to build the business first. You got to prove it out. Like, do that first with Horizon, and then you can build your own LLM over the next 5 years.
Going over to Kaushik, how does synthetic data compare to fine tuning with real data? That's actually an open question, to be honest. Synthetic data is a new feature that we've provided. And I think what it enables more than anything is getting off the ground with retrieval augmented few shots. And so that's what's really going to, I think, lead to that experiment. Rohan, did you use synthetic data for fine tuning? Is that something that you have any experiment with?
Not yet. We haven't used it yet. As we expand on roles in locations, we're going to need that because we're not going to have data off the shelf for roles that we don't support yet and we don't have data for. So we're going to get to that, but we just haven't gotten to it yet.
Gotcha. Okay. Going to Kevin's question about fine-tuning an open source model. Our hypothesis is like with fine-tuning, like it really depends on the use case that you have, right? So I mentioned like with one potential company that we've worked with, they were able to fine tune a model on a very specific data set that had a very narrow job, which was extracting information from a variety of different documents and synthesizing it for their customer support app. Not only did they have the volume of data, but they had the quality of data that allowed for good fine tuning. And as a result, they were able to get really good performance, and they were able to do it with the cheapest model from their LLM provider. So that worked for their case. It's just our experience that in the majority of the cases, you at least want to try retrieval augmented prompting, because I think it just usually provides the hits your performance benchmarks with a much lower cost. Cool. Any other questions from folks?
Wanted to let everyone know I did put a link to some synthetic data generator from Microsoft if you wanted that in the in-call messages.
Thanks, Link. Yeah, synthetic data generation is very interesting. Our pricing model. You know, we're open to chatting, Kevin. I think hopefully you'll find that we're very low cost if you're interested. And in many cases, at least for startups, we actually do not charge at all. So we'd love to chat if that's of interest.
We had to scrape through our couch cushions to pay Horizon. Found some quarters.
Okay. All right. I think with that being said, I don't see any more questions, so I think we'll wrap it up here and conclude this first webinar. Super happy and thankful for all of you to join. Thanks especially for Dan and Rohan to participate. I hope you found this informative. I hope you'll join us for the next webinar where we'll continue the discussion and other learnings. And as we mentioned, we're happy to chat and be a thought partner as you're productionizing your own LLM application. So feel free to schedule time. Otherwise, thanks everybody. Hope you have a good rest of your day and good rest of your week. Cheers.
Thank you. You too.